Yep. Okay. This week is super exciting. It is the technical practices one, and it has the first real exploration of that thing I was kind of confused about in week one, which was trunk based development. And I have since dug into it, and it's awesome. So, the first thing we want to talk about when we are talking about, I guess I should take a step back here. So, technical practices, the behaviors that we undertake as we engage in our working in our software development lifecycle, in our practice, our technical practices predict organizational performance. Okay? And that's I mean, and then which technical practices? Well, there's a list, and we'll talk about that. So here we go. So taking a step back into a historical context, I was actually a developer at this time. In 2001, I remember reading about this new fancy exciting thing called extreme programming, and for a little bit of context, I guess I kind of rolled my eyes at it even at the time because it was I don't know, there was this filmmaker named Warren Miller, and he would make ski and snowboard videos, and everything was extreme and radical, and like and the idea of extreme programming when compared to the extreme sports fashion of like helicopter ski. You take a helicopter up to the top of a anyways. So it seemed like a joke at the time, but it has really proven itself. It is in the realm of Scrum and Agile, but realistically, Agile is said to have basically won as the process to work in. Although I would like to explore that a little more at some point. I'm not sure that Agile, as prescribed in the Scrum Poker and things like that, is quite the right way to go. But anyways, so extreme programming is one of the methodologies, and it prescribes a few things. It prescribes test-driven development, continuous integration, and continuous delivery. The rationale for these processes is they enable more frequent, higher quality, and safer code releases. Okay? Because again, if you are doing test-driven development, you write your unit test before you write your code, and it helps you first of all, write testable code. Your code is tested before it even goes into the system, and that means because you have this very highly robustly tested system, it can go live in a much safer manner and more frequently because you test before you launch things. So we already know from previous weeks that continuous delivery has a measurable impact on business outcomes. And so that's what we're going to start by talking about right now. We're going to talk about the 5 keys to continuous delivery. So we'll go over here. We want to build quality in. We want to cease our dependence on manual inspection to tell us about quality, to report on quality, to provide quality. So build, and that is the unit testing, that is test-driven development. And the next one is working in small batches. This is where we start talking about trunk-based development, and I've got some resources there on the side that we're going to look at. So smaller chunks of work to deliver measurable business value early. You want to obtain your feedback or measurable business value quickly. You want to obtain your feedback early. It allows you to avoid any. I mean, if you've worked in systems where you have this real waterfall method, you can go through and build all of this stuff, launch it, and go, oh, this isn't right at all. This is garbage. We can't do anything with this. So by delivering in these tiny release cycles, you can get out of things that were not delivering business value much sooner, much earlier than going down these long waterfall, a 6 month or a 6 month project and going, this is stupid. What are we doing? And it also requires the small batches thing also requires that you change the cost of a deployment such that the cost is ultra low, and that's how you save money on your deployments and things. And so other features of continuous deployment, the computers are there to solve the repetitive tasks. People are to solve the problems. And so you want to automate your toil. You want to automate toil. That's your deployments. You're spinning up new servers. Your automated testing again. You want to relentlessly pursue continuous improvement. And so I'm also doing an algorithms course on the side, and I think it's either Skeena or Ruffledge. Oh my goodness, I should have his name handy because I'm like Tim Roughgarden. Oh, I was way off. Tim Roughgarden. One of the two of them says that the magic of an algorithms expert is that they're never satisfied. They say, can it get any better than this? And just like solving algorithms in your algorithms course, can we do any better? That's what we're talking about in continuous deployment. Relentlessly pursue improvement. And everyone on the team is responsible for organizational goals and over individual departmental goals. So a broad organization, you are more likely to be contributing to other teams' goals as needed. Obviously, good organization would mean that you maybe don't have to do that, but you do if you have to. So what are the foundations? The foundations of continuous deployment. This is pretty important here as well. You've got comprehensive configuration management, which means the effectively infrastructure is code, configuration is code, everything that you have to do in order to deploy your system is code, and it is checked into version control. So if you have, except for secrets, those are held elsewhere. Those are in a secret manager. But if you want to be able to spin up a complete environment from scratch, it should all be there. There shouldn't be any manual clicks or anything. You just run a one-line command, and it's up and running in the time it takes. I won't say no time, but mostly automated. So in terms of continuous integration, we'll talk about this one. This is where trunk-based development comes in. Keep your branches very short-lived. And so each branch should not be living for longer than a day. And I was speaking to some friends about this. How do you even do that? Well, you break your tasks down to the point where you can get the code in regardless of whether you're actually calling it. So that was the real trick right there for me. in understanding, if I've got this large project that I've got to figure out, and I've got it, let me back off of this for a bit because I'm using a lot of hand talking. So if I've got this large project that needs a lot of code, well, maybe I would write a function and I would get that function in, but I'm never calling that function. Now, maybe that function is incomplete, maybe it's not working properly, but if I never call it, that's not a risk to the broader organization. It's not a risk to the company or workflow. I've got time to work on phase 2 of this function. Let's fix up these little bits, or let's fix up these other dependencies or downstream issues, and then finally at the end of all of that, we'll bring it together and we'll call it when it's eventually ready. But the thing is, if I'm continually committing those things back into the main branch, we're never going to get into a massive merge conflict situation. And that's where the problem really, that's where much larger problems come in, is when we have a large number of merge conflicts. So this is talking about trunk-based development. So we're going to bring up, we've actually got a website that was supposed to be trunk-based development. So trunkbaseddevelopment.com. We have, so you can go look this up on your own. But this might be the system that you are used to, unless you are a far better developer than me or have worked in better places where you already do trunk-based development. But, so you've got your releases, right? And you check off of master, and you do all of your work up in this Git Flow area. This is typically referred to as Git Flow. And so you build your entire feature branch, and maybe other teams are building things as well, and you have massive merge conflicts when it tries to go back in. So you build your feature and you get it back in, and then things move forward. Well, with trunk-based development, we would look at something like this. Look at these little doopy-doops. These are these are just a day. This is maybe 2 days work. Anyway, so it's sort of like, you don't do these long-running features. You do this stuff and this stuff and this. You tiny little, pull it out, make a change, commit it back in. Well, how do you deal with the situation? How do you deal with this situation where you say, well, yeah, but it's not done and it can't go live like that? Well, that's where feature flags come in. So you wrap all of these things, all of these calls that you're not ready to use yet. You wrap those in a big old if statement, and you say, if this feature is enabled, then show my code. Otherwise, don't show my code. And that lets you bring this stuff back together. I'm sure as I dig into more about what this actually means and how this works and moves going forward, there must be other nuances to it, because this guy's written an entire book on it, so it's probably pretty nuanced in some ways. But anyways, this is that's the trunk-based development. So again, don't make your big features and let them run for days and days. Just take a tiny bit of code, less than a day's work, get that code back in, and that will help you on the continuous integration front. Finally, in terms of the foundations of continuous deployment, the things that we are building upon, developers should, so it's continuous testing. Developers should be able to run all tests on their own machine. They should be able to run frequently and fast. They should also, here's something, they should not need an integration environment in order to run. And so from that perspective, you should not have to spin up your entire application in order to run your tests. If you get to that position through the miracle of design, of the way that things happen, typically, in theory, those will run quite a bit faster than anything else. So we talked in, well, here we go. So that's the foundation. Continuous deployment drives team performance. Then the other thing, which we've already agreed as an industry is no longer negotiable, but we have version control. This is just use version control in your software development, and so version control is another thing that drives high performing teams. The version control is required to enable continuous deployment, and so all your code should be in version control. All application code, everything. All system configuration should be available to version control as well, whether that be whether your secrets be checked into a different type of repo or something. You should have your configuration should all be in version control. All individual application, so your infrastructure should be in version control as well as your application configuration, and that's where you would have secrets. You want scripts. You want all of the building and configuration of these systems, whether they be web systems or whether they be desktop apps. All of that should be built in, so there are no manual steps that need to be taken. When you have all of these together, you have a massive positive impact on software deployment performance. And as we've covered in previous weeks, software deployment performance predicts organizational performance, predicts market share, predicts profitability, predicts all of these things. And so it really is, we talk about the transitive property. If something downstream has an effect on this middle block, which has an effect on this thing. So it's actually, we can say, because version control affects continuous deployment, and continuous deployment affects organizational software delivery performance, and software delivery performance affects organizational performance, which affects market share, happy customers, things. We can actually say version control affects happy customers, right? So it's like you've got, I hope, I haven't gotten through the book yet, but I really hope at some point they draw this chain that goes all the way from using Git effectively to grandma's apple pie. I don't know. It's really cool how important these things are to the far end of the pipe, which is making organizational performance, whether that be profit or whether that be a not-for-profit outcome. So anyways, back on topic. So we've got version control also helps decrease deployment time. If you have all of your infrastructure as code, all of your configuration, all of your setup, everything, you have less team burnout and faster ramp-up time. I don't know how many times you've jumped onto a new project and you sort of check it out from version control, but not everything's there, and so you're running it and it doesn't start and you feel like an idiot and you're like, am I an imposter? Well, the fun part about a working system where you check it out, you run a command and it just works right away, you feel like a superstar when you do it like that, right? And so this correlation between high quality version control, high quality infrastructure as code, and job satisfaction and organizational alignment and identification with the organization. All of this stuff comes together to making happier teammates, to lowering the overall stress that you have to work with. So teams that do well with continuous deployment identify more strongly with the organization they work with. And so imagine that. Imagine high quality continuous deployment will actually improve your retention rates. So it's just a fascinating virtuous cycle. So two things that are highly correlated with continuous deployment. We've got a loosely coupled, well encapsulated architecture, and draw your attention back to the Clean Architecture series that I did, 15 weeks of architectural talks. Not as good as this, because I actually spend a lot more time talking to people who show up at the live streams, so be wary. It's not as good as this. not as compelling and wonderful and exciting as this amazing thing that I'm... Maybe if I knock this down, I'm not screaming in your ears. Okay, there we go. That's better. Sorry. Oh, anyways, so loosely coupled, well encapsulated architecture is important. So funny that a well-designed system. And here I got the Klepperman book right here as well, and designing distributed systems requires loosely coupled things. And so all of this stuff really comes together. And the other thing is your teams have to be able to self-select their tools in order to have high quality continuous deployment. So that would be, people are not working with a mandated set of tools that's maybe driven by somebody's kickback scheme. Anyways, so let's look at this. Here's one of these charts. So continuous deployment. I've got this. I did this diagram for us. It's from the book, but I just redid it, so it's sort of like I'm not entirely stealing it. So the impact of continuous delivery, it brings a massive payoff to the organization in the way that the work feels to people. You feel better when things just work, right? You show up at 9, you leave at 5, you're on call, your pager never goes off in your on-call session, everything's fine. I believe there are also rainbows and unicorns on every street corner in the land of continuous deployment. We'll figure that out. One day I'll get there and I'll tell you all about it. So, but they also, they say, because of the lower levels of deployment pain, the reduced burnout that team members might experience, your investments in high quality technology is an investment in the people of the organization as well. But you need, in order to do this stuff, you need senior leadership to buy in to funding this. You might actually need team members to help. You might need somebody to deep dive into these things. They are pretty complex. So this is the list of things that affect continuous delivery. But remember, continuous delivery affects organizational performance. It affects team and social cohesion. So likely potentially lower turnover, lower rates of stress, lower rates of burnout, higher, because you're getting your software out to the customer faster, you get your feedback loop faster, you are making happier customers, all of this stuff. These are the things. Version control, deployment automation, continuous integration, trunk-based development, which we talked about, test automation, test data management, which is just making sure that when you are running and writing tests, you have a robust set of test data. Shift left on security. This is interesting. We're going to talk about it in another week. It comes up soon, but so I'm not going to dive into that now, but shift left, if you have a timeline, right, typically the way of doing security is you've got your site under development and you get it up to this point where it's ready to go, and then your quality team runs a security scanner on it and comes back with a whole bunch of problems that you have to fix. Anyways, we talk about it in another week. But so effectively, shifting left means move it leftwards in the timeline. So you are starting security on day one, and we'll talk about that. So loosely coupled architecture, empowered teams, monitoring and proactive notifications. I haven't gotten to in the book yet, but I mean they're somewhat self-explanatory, but the detail will have to come later. But like we were saying earlier, it's really amazing to me how, so we look at this continuous delivery. This is one of those charts where we say continuous delivery results in less rework. In terms of identity, that's team members identifying with the team. It builds your software delivery performance. It builds your organizational culture, and it builds your organizational performance. These are predictive. These are actually predictive. It's important to note that when Forsgren, Humble, and Kim draw these arrows, they say, if we have continuous delivery, we can predict your organizational culture. Okay? So, but they actually go so far as to make claims that you can change culture by changing continuous delivery. So it's really interesting stuff. So let's go back to just me for a bit while I read out some more of this. How are we doing in time? This is a long one. I'm sorry. So continuous delivery systems impact software quality. They result in less we've just said all this. Skip it. Okay, so we've talked about version control, test automation. There's an interesting bit here about how do we deal with, so we want reliable automated tests. We want our fragile tests to be in quarantine. I hope they talk a little bit more about what that means later. Code becomes more, this is important, code becomes more testable when developers are responsible for writing the tests. So you should not have a team, should not necessarily have a team of people who are test automation engineers who exclusively write tests and have no influence on the structure and the style of the code. When developers are primarily responsible for the tests, they care more about them. Test data management is just having a robust and reliable set of test data that resembles production enough that you can get good information out of it. And so the trunk-based development we focused on pretty deeply, I think. Information security, we talk about dealing with our InfoSec earlier in the process. That's what shift left means in terms of a timeline. The left is at the beginning of the timeline. And integrating security practices early is strongly correlated with high-performing teams. I don't know if you've ever had CWE show up at the end of development where it's really deeply ingrained in your systems, but it is a nightmare. So Here we go. Adopting continuous delivery. It improves culture, reduces burnout, reduces deployment pain, so you're not afraid when you hit the go button. Sometimes if you are implementing continuous deployment, it requires that you rethink everything. And what do we mean by everything? I wish I had written it down. I think that's a lot to do with architecture and how things are done, especially around testing. There's a lot of work to do when you want to add tests to something that has been written without tests. You typically have to do massive refactoring to break things apart. Right, and so you need to work relentlessly to simplify your architecture, further separate your concerns. You want to make sure that your automation is not prohibitively expensive. In fact, architecture is, if not the primary obstacle to CI/CD, it is one of the most important aspects of dealing with a CI/CD system. And dun 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 dun, that's what we talk about in the next chapter. So for now, we are done, and bye.